Last time, we left off at a pivotal moment in our planet's history, the origin of life. A quiet, microscopic beginning in a world still reeling from chaos. But what exactly was that first life? What did it look like? And how did it change everything? Let's rewind to about 3.8 to 4 billion years ago. Earth was cooling, water had formed oceans, and volcanic activity bubbled beneath the surface. In these oceans, something remarkable was happening. The primordial soup, a mix of water, minerals, and organic compounds, was a playground for chemistry. Molecules collided, broke apart, reformed, and slowly something new emerged: life. The first life wasn't anything like what we see today. No plants, no animals, not even cells with a nucleus. The earliest known life forms were prokaryotes, simple, single-celled organisms without internal compartments. Think bacteria. But not just any bacteria. These were ancestors of all life on Earth. You might wonder, how do we even know this? The oldest evidence of life comes from fossilized microbial mats called stromatolites, found in Australia and dated to about 3.5 billion years ago. These layered structures were built by colonies of cyanobacteria, some of Earth's earliest architects of life. We also have chemical signatures, ratios of carbon isotopes in ancient rocks, that suggest biological activity even earlier, possibly up to 3.8 billion years ago. So how did non-living molecules turn into life? That's the big mystery called abiogenesis. While we don't have a complete answer yet, there are some strong hypotheses. One idea is that life began near hydrothermal vents, hot cracks in the ocean floor that provide heat and rich chemistry. Another is the RNA world hypothesis, which suggests that RNA molecules, capable of storing genetic information and catalyzing reactions, were the first building blocks of life. Interestingly, not all early life was the same. There were two major domains, bacteria and archaea. Both are prokaryotes, but they're as different from each other as they are from us. Archaea are often found in extreme environments, boiling hot springs, salty lakes, acidic vents, just like early Earth. This means they might resemble the kind of life that first emerged. In fact, some scientists think we might find similar organisms on other planets, like Mars or Europa. All life on Earth today, from blue whales to banana trees to humans, traces its lineage back to these tiny single-celled organisms. They were the origin point, the first chapter in a story that would eventually include dinosaurs, civilizations, and space travel. It's humbling, isn't it? That everything we know, everything we are, started from something invisible to the naked eye, floating in a hot ancient ocean. Next time, we'll dive into one of the most dramatic plot twists in Earth's history, when life started to change the planet itself. Yep, we're talking about the Great Oxygenation Event. Until then, keep wondering, keep exploring. You're a part of the oldest story ever told, the story of us.